I think the fifth question, but anyway, it's the height of male Swedes. So we read through this. Among various ethnic groups, the standard deviation of height is known to be approximately 3 inches. So notice this is one where we're ethnic groups, the standard deviation of height is known to be approximately 3 inches. So this is a standard deviation, and it's coming from the sort of the population of ethnic groups. So this was a population one. We wish to construct a 95% confidence interval for the mean height of male Swedes, a, a ethnic group within all the other ethnic groups. 48, and notice they're all doing it in words rather than numbers. So 48 male Swedes are surveyed. That's our sample size. I like to write it out as numbers. This is going to be a population standard deviation of 3 inches. I write that out. The sample mean is 71 inches, so sample mean is x bar. Sample standard deviation is 2.8 inches. I guess we could use either one. Constructing 95% confidence interval for the population mean height of male Swedes. For the population mean height of male Swedes. Okay, so that's the population. We're talking about just male Swedes among various ethnic groups. Could we use this 3? I think, well, if you did a z-test, you would want to use the population standard deviation of 3, or you could do, because of the information they gave us both, you could do a t-test because they gave you the sample standard deviation. I'm going to do both with this, but I'm going to, since they gave us a sample, I'm going to do this one as a t interval again, because why not? And why? I'm just going to be shorthand. Standard deviation came from sample. State your confidence interval. So let's just calculate it, and then you'll see we'll be able to do this actually relatively quickly. We'll do a t interval, and we'll switch over to z interval. I think we should get pretty good stuff. Let's see. Our mean is given as 71 inches, but we might get something a little different. 2.8 is our sample standard deviation, and our sample was 48. 48. We want a 95% confidence interval. Got that. All this stuff is good, but we can just margin of error. It's all going to be summarized for us on the next page, and that's what we will use. Confidence interval is that the mean is 71 inches plus or minus 0.813. I'll go for 3 standard deviation or 3 decimal places. What's the confidence interval inequality? 70.19. And here I'm just going to go, or sorry, 8. What did I say? 8 to. Oh wait, I'm looking at the wrong place. 70 point. Yeah, I was right. 1.8 or 1.9. I was looking in the wrong place. So you make a lot of errors when you look in the wrong place. So this was 71.19. I'm going to round that up to 2 decimal places. And then this one would be 71.81. Okay. And then for our drawing here, the mean is 71 inches, ranging from 71.19, maybe just go 71.2, it's an inch, right? To 71.81. Explain in one sentence what this confidence interval means. We are 85% confident that the true mean of the population of male Swedes is between, I go 71.2 to 71.8 inches. It's okay, either way. That's pretty much it. Now, what I'm going to do, I'm going to back up and just, if you're done, you're done. And this is all good. I just want to see for personal, what would if we did a z-test? If we did a z-test, we should use 71. We still have to put our data in. Now we use the standard deviation from the population, which was 3, not 2.8. But the sample we had was 48, 95%. Let's see if we get exactly the same. I think we'll probably be a little different. Looking good. Let's see. 71.84. We had 8.1. So we get a little bit of difference between a T and a Z. But maybe not that much. You know, if you're looking at the rounded to 1 decimal places, this is 70. Oh, did I get that right on the other one? 70.15. Actually, there's quite a big difference here. Did I get that right? And I got to check back. Did I went to the T? I'll let this change. 71 in here. And we had 2.8 in here. And then we had 48 here. Got all that. I was looking carefully. That's 70.2, not 71. Yeah, because how would you get up? Sorry about that. I don't erased it. So 70. So they're much closer. Good thing I did a double check because you were probably wondering what's he doing. It's 70, not 71. And so down here, we need to the 72. But you see, because there's really not that much difference between a Z and a T, especially rounding to 1 decimal place. We would have these same values. Either way, we're pretty close. All right, that is this one. One more set of questions after this, and then we're good to go.